Thanks, everybody. Oh, wow, that is loud. Thanks for joining me today. I know there's another infrastructure as code talk happening or like a panel discussion happening right now. So I really appreciate everybody choosing to join me today. I'm going to talk to you about the decisions you would make when you are going to choose an infrastructure as code solution. But I'm going to try and frame it in a slightly different way than the usual kind of things that you see in articles on the internet around tables and all that kind of stuff. So before that, I'll just quickly introduce myself. I am now a solutions engineer at Pulumi, but prior to that, I was an infrastructure engineer or a platform engineer or a site reliability engineer or a DevOps engineer. Held all those titles, did the same job for 10 years. You can find me. I have a Twitter account. I have lots and lots of code examples in GitHub, especially some of the things you're going to see today. And I also occasionally write on a blog at leebriggs.co.uk. So a lot of the stuff that I'm going to talk about has been framed by long, lengthy blog posts, but you may have more fun listening to me talk about it today. So what are we going to talk about today? Quick agenda. We're going to talk about the history and like the beginnings of infrastructure as code and how it kind of derived itself out of configuration management. We're going to talk about one of my favorite topics, imperative versus declarative. We're going to talk about one of the most important parts of an infrastructure as code tool, the DAG, or the directed acyclic graph. And then once we've kind of laid that groundwork, we're going to talk a little bit about what the user experience looks like when you're choosing an infrastructure as code tool. So no more comparison tables. I'm not going to throw up a bunch of slides with comparison tables. We're going to look at it through a completely different lens. And then hopefully by the end of this, you'll have an idea of the different types of experiences that you want to have when you're writing and maintaining infrastructure, but also what types of experience you want to provide within your company, within your organization. So quick disclaimer. As a solutions engineer, that means I work in software sales. I am not here to sell you a product. I'm not here to sell you Pulumi. If you accidentally want to buy it after I'm done here, that is just an accident. I did not set out intentionally to try and sell you anything. I became a solutions engineer because I like helping people and I like helping people make decisions. And as a result of that, I feel like I've talked to at least 300 customers in the last 3 years about how they have defined the infrastructure that they want to maintain and what choices they had to make while they were getting there. So let's define infrastructure as code. Let's go ahead and do that. Like, just quick show of hands if you are using an infrastructure as code tool right now. I would put that about 2/3 of the room. Raise your hand again if you like or are satisfied with that infrastructure as code tool. A lot fewer people. So I imagine a lot of the people who have attended today are trying to get an idea of what the other alternatives out there and what things that you are going to look at. But before we do that, we have to actually define what infrastructure as code is. So when I started out building infrastructure, this is what infrastructure looked like. We would all rack and stack data centers and we go to different parts of the world and point of presences and rack huge amounts of data centers. And this is an accurate example of my cable management. And that was how we got infrastructure. I remember a software developer coming to me around about 10 years ago and saying, we got this new application and we got to get it out next week. And I was like, well, it takes 6 weeks for the service to arrive. So I think you're in trouble. And nowadays, infrastructure looks like this. You go to your cloud provider of choice, and if you really hate yourself, you go and click on a bunch of things in the UI and spin up a bunch of infrastructure, and it turns up in seconds. And that paradigm shift, that change of using APIs to create infrastructure is really where infrastructure as code started. Once we got to cloud providers and once we realized that we could use APIs to spin things up, we needed a different set of tools than the tools that we were using at the time to actually manage that infrastructure. And I started out in configuration management and tried to use configuration management to talk to APIs. It was a miserable experience. And we ended up with a whole new paradigm, a whole new set of tools in order to do that. So configuration management was something that we, at the time, were using to manage operating systems at the kind of like server operating system level. And as a result, an offshoot of that came infrastructure as code tools. And it can often be difficult. I've seen lots and lots of people saying that they're doing infrastructure as code, and then I ask them what they're using, and they say Ansible. And I'm like trying to keep a straight face, because to me, Ansible is an infrastructure as code tools. It can actually, configuration management tool. It can talk to an API, but it's not a great experience in doing so. So what I've tried to do here, and this is very much a work in progress, and if you want to talk to me about after this about what you think the difference between configuration management and infrastructure as code is, happy to listen to any thoughts and opinions here. But generally, the difference between configuration management and infrastructure as code is what layer they operate at. Whereas configuration management talks at the operating system level, infrastructure as code will generally talk to an API. The most important thing that I think is on here is this third line talking about the graph of infrastructure that you are maintaining. Almost all infrastructure as code tools, in fact, all infrastructure as code tools build a graph of the infrastructure that it's maintaining. And it does that by storing state. And I'm sure there's people around the room going, well, hold on a minute. That's not true, but we'll get to that, I promise. The other thing to think about is kind of this differentiation between declarative and imperative. Like, we're going to talk in length about this in a few moments, but almost every infrastructure as code tool is declarative. And I will argue with you to great lengths about why you are wrong about some infrastructure as code tools being imperative. But a configuration management tool can be either imperative or declarative. Like Ansible, while using a configuration authoring model in YAML, is a set of imperative steps. And so it's an imperative tool. Puppet, on the other hand, is a declarative tool, but it uses a DSL. So you're going to talk a little bit about how you differentiate those things as we go along this talk. Now, the most important part of this is that we all decided at some point that I can't really pinpoint in the history of infrastructure code that we were going to get done with imperative and we were going to go declarative with everything. And we wanted to have this experience of being able to describe what our infrastructure looks like, and something kind of comes along and makes it look like that for us. And the way that that happens is the same in almost every infrastructure as code tool. And I'm kind of like caveating that a little bit. But the difference between some of them is how much control you have over whether you build that graph, this directed acyclic graph. So what is that? Well, this is a directed acyclic graph. It is a bunch of nodes in a graph, or a bunch of things in a graph, that will allow you to spin up infrastructure or create things in a specified order without you having to make decisions. And so what this actually looks like in real terms is, in a cloud provider, you have a VPC, for example, in AWS, then you have a subnet, and then you have a NAT gateway, and then you have a VPC endpoint. If you were to do those things in imperative manner, you as the operator would need to make sure that those things happen in the right order. You would need to say the VPC first, and then the subnet, and then the NAT gateway, and then the VPC endpoint. With a declarative tool, all you have to do is point things at each other. So you say, well, the subnet API has an input of the VPC ID, and you let the tool figure it out for you. That is the difference to me between imperative and declarative. So we're going to go back a couple of slides here, because I have these slides in the wrong order. And we're going to talk a little bit about the declarative and imperative differences. So an imperative tool means that you, as the person who is operating and maintaining this thing, is the person that decides what order things happens in. And if you are doing it declaratively, you don't have any control over the way things happen if you're passing inputs and outputs to different resources. So you are building the graph in an imperative tool. In a declarative tool, the tool builds it for you by just you expressing what you want things to look like. So ultimately, in an imperative system, you as the operator make the decisions. In a declarative system, the tool itself makes the decisions. And what does that look like in real terms? Well, here is two examples of code written in Python to create an S3 bucket in AWS. On the left-hand side, all I have to do is say, create me an S3 bucket. On the right-hand side, I have to try and catch exceptions and actually figure out what happens if I get an error. If that wasn't there, things would go badly. But in a declarative tool, you don't have to actually do these conditionals, these if statements, these try catch, these different things in order to actually make sure that this thing is going to be successful. So one of the interesting things about creating these graphs that we can see here is that we realize that these graphs are really, really important because it really reduces the amount of code and logic you have to put in your infrastructure management. And so we started using configuration languages to describe them. That might be JSON, it might be YAML, or generally will be YAML. If you're really miserable, you might use something like XML. But ultimately, these configuration languages are really, really good at describing the state of a system, because you don't need any conditional things in there like we saw here. Like, you don't need to actually use a conditional for when you're creating an S3 bucket and to actually get response from the API. However, YAML is terrible. I don't think I've met anybody who loves writing YAML. I don't think anybody really likes it. And if you do, come and see me afterwards and tell me why, because I'd love to know. It's just everywhere now. YAML is all over the place. And one of the things that is really, really important about these configuration languages is that while you don't need to do conditionals when you're creating your resources in your cloud provider, you do need to manipulate the graph that you are creating. And you can't do that with a configuration language. So what do I mean by manipulate the graph? Well, let's say you have a production and development environment, right? And you want your development environment to not cost as much money as your production environment because it's a development environment. So you've decided that you're going to have less subnets in your development environment. In your production environment, you're going to have multiple subnets across multiple availability zones in your cloud provider. But in development, you're just going to have one because you're not really worried about cloud provider outages for your development environment. So now you need to manipulate the graph that you're building. Now you need to, and in order to do that, you're probably going to need a conditional statement. And so what we ended up doing is we created domain-specific languages that spit out configuration languages in order to allow us to manipulate this graph, to be able to create resources with different conditions. Now, this is where a lot of people come along and go, I saw an if statement in your infrastructure code, therefore it is imperative. And my argument to that is, you can do those same things in all of these DSLs. You just don't have an if statement. If you've used Terraform before, you probably use count equals 0. That is just a really, really rubbish if statement. It's the same thing. So if you're going to say that there's a conditional in an imperative infrastructure defined program, then all of them are imperative. And if you say that that's not the case, then all of them are declarative. So that's how I came to the conclusion that every infrastructure as code tool is declarative. Happy to have long, vociferous arguments about this after this talk. But ultimately, these DSLs came along to allow us to manipulate the graph of infrastructure that we're building when we're actually doing this declarative thing. So now that we have this foundation, now that we have this understanding of what we're actually doing when we express infrastructure with infrastructure as code, we're building this graph and we're doing it in a declarative manner. How do we actually want the people who are defining infrastructure to have this experience? And I think this is a really important question, especially in the in the year 2023, because we've gone from in an ideal world, we've gone from a place in which there's a small team of operations folks creating infrastructure to now everybody in the engineering organization is expected to create infrastructure. I previously worked in an organization in which non-technical users were expected to spin up the entire application. And if you tell them the first thing you have to do is download Git, and they go, "What's Git?" you know you're in trouble. But that was a requirement. That was something that we had to do in order to make sure that we were commoditizing the application we were building. And so we need to think about what the user experience looks like in order to actually make this a successful thing. You may have heard the term platform engineering. Apparently, it's the new hotness. I have some opinions about that, which, as you can probably tell from the way I'm talking, I have opinions about everything. But the user experience is essentially a way of defining what you want an internal platform to look like. So let's talk about that for infrastructure as code. Well, you've probably read multiple articles that say, how do you choose an infrastructure as code solution? And you see a table like this. And my reaction to these tables is, how is that helping me make any decisions at all? How is this giving me any contextual information about what experience you're going to have when you choose an infrastructure as code tool? Because if you look at this, the clouds that an infrastructure as code tool is probably important, but what on earth does deployment history and infrastructure cleanup and code reuse and state files? Why do I care about state files? Is that something that's important to me? Maybe, but it's probably not important to everybody in your organization. What they really want to do is just be effective at getting infrastructure off the ground. So I like to express this in a slightly different way when I'm talking to customers or talking to budding infrastructure as code organizations. I like to look at it through two different experiences. And when you're creating infrastructure, there's two things that you actually have to do. The first is you have to express what that infrastructure looks like. And then secondly, you have to get that expression of your infrastructure into the cloud provider itself. So I like to call these the two experiences: the authoring experience, which is how is it going to feel for me to actually write this infrastructure out and make it look like I want it to, and then the execution experience. How do I actually get what I've written into the cloud provider? How do I make the cloud provider know about it? How do I send it to the API? And you can really boil that down into how do I express this graph that I want to build, and then how do I actually create and run this graph? Or you can really break it into a lot more granular things. So you could say, what kind of language do I want to use? How abstracted do I want that to be from my end user? Which cloud providers do I actually want to support in this authoring experience? And like, do I actually want this to be easy with a language server, or do I want to do it the hard way and write it all out on a piece of paper and throw it at a printer, or a fax machine? The execution experience is basically broken down into an opinionated or an unopinionated execution experience. And I'm hopeful that will make a little bit more sense as we kind of go through the rest of this talk. So let's look at those two experiences and what it looks like with all of the current available infrastructure as code solutions. So the authoring experience. We already talked about domain-specific languages, and domain-specific languages kind of crept up as a result of us wanting to manipulate a graph of infrastructure. The thing about a domain-specific language is it's domain-specific. It's only got a single purpose, and that's for that particular tool. I spent 10 years learning the ins and outs of the Puppet DSL, and that is now essentially useless to me. I'll never write a single line of Puppet code ever again, probably, and that's 10 years of learning just completely down the drain. That Puppet language is just not something I do on a regular basis. Now, I learned a lot of fundamentals with that, but the things that I actually learned from Puppet were not the things that essentially have kept me moving forward in my career. The expressiveness is generally a feature in a domain-specific language. The number of times I have heard that the Terraform DSL is great because it limits what you can do is very, very high. Like it's almost every conversation that I have with somebody who really loves Terraform. The lack of expressivity in that HCL domain-specific language is a feature, and it's there intentionally. Now, I have some opinions about that, but that is the same of all domain-specific languages. They may be Turing complete, but they are limited in their expressivity on purpose. However, they are simpler. They have a much lower learning curve for people who are just getting started with infrastructure code. When you want to kind of build an abstraction, so that's like a bundled piece of infrastructure that you're going to provide to someone, you have to build your own abstractions. And the success of the language server, which is the thing that's inside your integrated development environment that makes it easier for you, is basically down to the person who owns that domain-specific language. So a great example of this, if you want to write Puppet code, you have to install the Puppet language server in order to actually get autocomplete in your VS Code or something like that. And just a quick aside, actually, I think there's a slide in here, but just a quick aside, if you are using if you are writing infrastructure and you're doing it on Notepad or VI or something like that, please don't. Try something else. It's way better. These are the DSL-based tools that you can choose from. So everybody, I'm sure, or at least most people in this room will have heard of Terraform. If you are in the Azure ecosystem, you may have heard of Bicep, which is a lovely little play on words for the ARM templating language. So they called it Bicep, which I thought was reasonably cute. But these are the two main DSL-based tools. So if everything that you've heard so far about DSLs is making you think, I want to use a DSL, I think a DSL is the right way to go for me, these are the two tools that you're looking at. There are many of the tools that are out there have configuration-based language support. So this configuration-based language support is very, very limited in scope. It's really, really lacking in expressivity. If you want to get expressivity into your infrastructure as code tool, you'll need to introduce a templating engine on top of the configuration language. The most famous example of this is Helm. If you're in the Kubernetes ecosystem and you've used Helm, you've probably written a Helm template with Go templates on top of it. And if you're like me, you probably wanted to claw your eyes out. It's a miserable experience. But that is the necessary thing that you have to do if you are manipulating a graph of objects in a configuration language. You have to put a templating system on top of that. The bonus for this is it's really, really simple. Like most people that I know that are getting started in infrastructure as code or in general technology can write a YAML file relatively easily. They are great for getting you off the ground, and they're really, really great for starting you out in your journey. But you don't have any of this IDE support, and probably keep thinking, you keep talking about this. The biggest difference maker in expressing infrastructure or writing effective software is a language server that's installed in your IDE. Makes your life much easier. It stops you looking up different properties and things across different tabs and screens. It's just something that I would highly recommend. If you're using YAML, you probably can't use a functional language server in order to make your life a little bit easier in your authoring. So these are all the tools that support a configuration language-based mechanism. Terraform, if you really want to, will allow you to express infrastructure directly in JSON. Pulumi has YAML support. Crossplane is a Kubernetes-based infrastructure as code tool that will allow you to provision infrastructure via YAML documents that you throw it in a Kubernetes cluster. CloudFormation is arguably the first infrastructure as code tool and will allow you to offer infrastructure in a YAML-based format or a JSON-based format. And then there's the Azure Resource Manager in Microsoft Azure, which is colloquially called ARM. The final one of the authoring experiences that you can expect to see in your journey of infrastructure as code choosing is the programming language-based authoring model. This is extremely expressive. It gives you the full capabilities of the language at your disposal in order for you to express what you want this graph of infrastructure to look like. This expressivity comes along with the language. The language is built to do a bunch of things like build applications or build websites or build back-end infrastructure. You can use all of those features in most programming language-based authoring models. You use the abstractions that you are probably familiar with in those languages. So object-oriented classes or whatever, a pip package, a NPM package, a Go module. Those abstractions are built into the language. Now, if you've written any software in any of these languages, this is all second nature to you. You already know how to do this. And so it becomes really, really natural. However, if you have never written anything in those languages, it's got a really steep learning curve. You can't just say, choose an infrastructure language like TypeScript. Cool, let's just get started. You have to understand the fundamentals of TypeScript before you actually get down that path. You have to kind of know what a Python interpreter is. You might want to know what a pip package is. All those things are requirements if you want to do programming language-based authoring. However, they do have something that I personally think is important. All the languages I mentioned so far have a type system built on top of them, which dramatically reduces the number of errors that you make when you are expressing your infrastructure. Some DSLs have that. The Terraform HCL DSL has a type system associated with it. Not all of them do, but that type system, it can be really, really useful when you're using programming language-based authoring mechanisms. So these are the tools that currently allow you to support programming languages to author your infrastructure graph. The CDK, the Cloud Development Kit, came out of Amazon Web Services. And it essentially allows you to compile CloudFormation templates. And then HashiCorp went and used the Cloud Development Kit to allow you to express Terraform HCL or Terraform infrastructure using the Cloud Development Kit. Pulumi built, and obviously I'm wearing a Pulumi t-shirt. I work at Pulumi. Pulumi was built with programming languages as its first order of mechanism. So programming languages there is no intermediary compilation step. With the Cloud Development Kit, you express your infrastructure, and then you do this synth command that generates a bunch of configuration language. With Pulumi, it just goes directly to the API. And so those are the kind of main differences between the different authoring models with programming language-based. But if you use any one of these three tools as a programming language-based authoring model, you will get all the benefits that I just talked about here, which are often really, really useful. So this is a very hastily thrown together Venn diagram of what that looks like. My personal belief here is that the thing that will allow you to offer the most authoring experiences within your organization is going to be the most effective. And the reason for that is that if you want lots and lots of people within your organization to express infrastructure, you have to offer multiple authoring models to make everybody successful. You remember my story earlier on where I talked about non-technical people? YAML is great for them. If you have a team of principal software engineers who are adding really awesome features to your application and they want to ship that to the cloud as fast as possible without you as an operations person getting in the way, a programming language based authoring model is going to make them very, very happy. And I know that because I talk to them every single day. The number of people who I have been on the phone with in the last 3 years who have said, our team is using insert infrastructure as code tool here, and we don't understand it. And we want to use Pulumi because it's got a programming language based authoring model. And all of a sudden now we have a shadow IT system where the operations people are upset because they're not using that original infrastructure as code tool and they just want to get things done faster. All of that was because of the programming language authoring model. Like almost all of those people want a programming language authoring model. So if you are using one of the other tools that doesn't offer a programming language authoring model, I would suggest asking the developers that you support, if you're an operations person, if they like what you're doing and if they would consider doing something, if they could use the language they're building their applications in to express infrastructure. It's an interesting strategy, and it generally will get you good answers. So I mentioned earlier, anybody who's using those programming language based, authoring tools, and they're having a really poor experience, and they don't really know why they're not getting it, and then they tell me that they're using VI in order to actually express their infrastructure. I'm like, well, of course you're having a poor experience. You're doing everything by hand. Like, I turn on GitHub Copilot and all my language services, and most of the stuff gets written for me. I don't even have to type it out most of the time. We'll eventually get to the point where it can understand what I'm thinking and just does it all for me. But it's a much more expressive and productive way to describe infrastructure if you just use the right tooling alongside the right stuff. So we talked about the authoring experience. Let's now talk about the execution experience. So we've written this wonderful piece of infrastructure, and we know it's awesome, and we know we've written it down, and we now need the cloud provider to know about this infrastructure. So how do we execute that infrastructure now that we've written it? There are 3-ish main ways of doing this. The first is the command line driven experience. So that gives you lots and lots of control over the way you execute those things. Generally, you'll see a command line execution experience inside a CI/CD pipeline, or like Jenkins, GitHub Actions, Circle CI, something along those lines. Or you might run it locally from your laptop, but that gives you control. It gives you the ability to choose how things are executed. It gives you the ability to decide when and where that happens. You might want to implement manual approvals. Lots and lots of control with a command line driven experience. It's also opinionated in a lot of cases. So, for example, if you're a Terraform user, you probably understand the Terraform plan, Terraform apply model. That's a very opinionated model. The tool has decided for you how that execution experience should look. Because you have a set of steps that you need to do in order to get it to work. So again, in Terraform, you have to do Terraform init, and then you have to do Terraform plan, and then Terraform apply. Pulumi, you have to do Pulumi up. All the different command line based experiences have this opinionated layer on them that means that you have to do them in a certain way. But they are also, in almost all cases, extremely fast compared to the other stuff we're going to talk about. So you can do these things in parallel. You can manage different pieces of infrastructure as you wish. You can, increase the size of your EC2 instance that you're running on to make it faster. That is all a part of the control that we talked about a few moments ago. These are the 2 main command line driven tools. So Pulumi has a CLI that you install. Terraform has a CLI that you install. And again, those are the most popular way of driving an execution experience. The second execution experience is the server-side execution experience. This is a much, much more simple, abstracted way of you being able to actually apply infrastructure to an environment, because you hand off the responsibility to the tool itself. People will always say with a command line driven experience that it has to have state management involved. All infrastructure tools have state management involved. Server-side tools have state management involved. The difference between them is that in one, you have control over the state. In another, you do not. So CloudFormation and Azure Resource Manager are both server-side driven tools. They both maintain state. You just can't touch it. You're not allowed near it. It's all on the back end of the actual tool itself. So the state is managed for you, which can often be an appealing thing for people who have gotten into a mess with state before, who have had infrastructure outages because of their infrastructure as code tool. The problem with it is that it's really, really slow. I have a customer that I worked with to migrate off CloudFormation, and they moved all of their infrastructure from CloudFormation to Pulumi, and they measured how much their deploy time reduced, and it was 10 times faster than CloudFormation. Now, if Amazon Web Services wakes up and makes it faster, that's great for everybody, but you don't have any control over that. You can't make it faster. You can't throw more resources at it and make it go quicker. And in a deployment scenario, especially in an outage, I have personally had to watch CloudFormation do its thing and then get stuck in rollback something, whatever, broken in the middle of an outage, and then like wanted to actually tear my hair out because I'm just waiting for CloudFormation to do its thing. That is a measurable impact on productivity for lots and lots of organizations. And if it gets stuck, like I said, if you've used CloudFormation, you may have got stuck in the rollback not complete error mode. There's nothing you can do about it. You have to open a support ticket with Amazon Web Services or just delete the thing and start from scratch, which is really not a great experience. As you could probably tell from what I'm talking about, from the way I'm talking about this, I don't really think that server-side execution experiences are a very desirable way to go, but there are lots of organizations that want to do it that way for all of the reasons that you see in the simplicity section here. So then a kind of offshoot of that server-side based experience is this Kubernetes based experience. And so what this creates is like an internal server-side experience where you have this API, which is a Kubernetes cluster. And then you throw the configuration at the Kubernetes cluster. The Kubernetes cluster handles the state for you, and it gives you kind of like a faux server-side experience, but one that you control. You get all of the great things that Kubernetes brings with you to the equation. Like you get this automatic reconciliation loop. So if anybody modifies any cloud resource, the Kubernetes reconciliation loop will consistently bring it back into compliance. But this is an incredibly complex way to do things. I have personally tried this. I have run half a dozen to a dozen Kubernetes clusters at a previous organization. It's really, really complicated. Like I'm sure you've all seen that meme, like how to draw an owl, like draw the head and then draw the rest of the effing owl. Like that's essentially what the Kubernetes experience looks like. If you have a large Kubernetes-based implementation at your organization, this will probably be very attractive to you because you've already done the work to get Kubernetes up and running. If you haven't touched Kubernetes at all, this is going to be really, really daunting for you to go down this path. These are the Kubernetes-based tools. So Pulumi has a Kubernetes operator that allows you to describe infrastructure in all of Pulumi's supported languages, and then the Pulumi Kubernetes operator runs inside the cluster and gets you this continuous reconciliation loop. And then there is Crossplane, which is based on Kubernetes as its execution mechanism from the very ground up. So you get all of the benefits of the Kubernetes ecosystem with Crossplane, and there's lots and lots of great content out there around how this looks for Crossplane. So these are, again, another hastily, shoddily thrown together Venn diagram that shows you all the different execution experiences that you can really hope for. And ultimately, this is really a choice that is really just as important as the authoring decision that you want to make. And the reason for that is because not everybody wants to run a CLI tool in your organization. Not everybody wants to sit and wait for a CI/CD pipeline to run before you can actually get some infrastructure up and running. Not everybody is going to get access to your production environment. So the different thought processes that come with these execution experiences are really, really important decisions to make when you are thinking about an infrastructure as code tool. There is one other execution experience that I think is really starting to make to rear its head, and I mentioned it at the beginning of the talk around platform engineering. So, platform engineering is this kind of new mechanism that allows you to build this platform of infrastructure provisioning without having to actually do any of the stuff we've already talked about. Pulumi has a feature called Automation API that allows you to build these platforms. I have seen platforms built with all the other tools like CloudFormation and Terraform, and that platform is essentially a Git repo that you submit to, and then a bunch of stuff happens, and then infrastructure comes out of the other end. But that to me is not a platform. If you're telling people that in order to provision infrastructure, they have to download Git and send something to a Git repo, is that really a platform experience? Is that really what you want to build? Like, really what people want is something like Heroku or something like you know, Google Cloud Run, where they just make an API call and everything happens for them. Pulumi's automation API allows you to build that yourself, but it is not a simple task. It's a really daunting task, and platform engineering is the new hotness. But I think it's going to be an interesting few years with this platform engineering kind of interest sparking, because the thing about building a platform is you're building a product. You're building an internal product for your organization, and they're not easy to build. So you're in an organization and you've listened to me rabbit on for 35 minutes now, and you think you've made a decision about which infrastructure as code tool you actually want to use. Like, you as an individual have decided. Well, here's the most important thing to remember. One person should not make these decisions for a whole organization. And the reason I know that is because I did it and I made huge mistakes. I tried to push my opinions onto an entire engineering organization, and everybody pushed back against it. And it wasn't a great experience for me or for them, because ultimately everybody in your organization needs infrastructure in the cloud. Everybody needs it, from your test driven development team, your front end team, your back end team, infrastructure people, security people. They all need to provision infrastructure within your organization. So the real question that you get left as an infrastructure engineer or a DevOps person like me is, do I do it all myself, or do I go around and clean everything up and do it right, or do it right, and do it the way that is supposed to be done in my mind? Well, what I started to realize, and I've realized over the last 3 years as I talked to hundreds of organizations that are adopting infrastructure as code, is that you need to choose something that will allow the vast majority of your organization to feel like they can be productive, and and can actually move things faster. Like, you'll notice a star here around, like, around the first sentence, but the thing that always gets forgotten is that you can't make everybody happy, but you should try, right? Like, you should try and choose a tool that everybody wants to use or everybody's interested in. I already mentioned all these different organizations. I mean, the marketing team needs to update the website, right? Like, do you want them coming to you every single time they want to update DNS records? I certainly don't. And so everybody needs to be able to be effective with infrastructure in a fast moving and effective organization. So how do you choose something with all the things that you've heard me talk about so far? How do you choose something that helps them be productive? Well, the thing that really, really boils down to me is that productivity will always beat correctness. Like, I'm personally one of those people who will get really like bent out of shape about something just not being right. Like, this is not the most efficient algorithm to use, and this is not the right way of doing this, and this is not the best thing to do here. Well, the reality of the situation is that that isn't going to make this company that you work for any money. Like, implementing another more efficient algorithm isn't always the right thing to do. So I've started in the last 3 years to skew my ideas towards productivity over correctness. And what I mean by that is, what is the thing that I can help an organization do when they're choosing the infrastructure as code tool that will allow the most people to be effective at getting their job done? So, there's a really great article that I read a long, long time ago on this, all like less is more. Well, the actual answer is that less is less. Like, let's try not to screw things. Like, if something that you've already done is working, don't mess around with it. Like, you're probably here because you don't like your infrastructure as code tool. Or, I remember the raise of hands, like half the people here were like, I'm not really super happy with my infrastructure as code tool. It is in my vested interest to make you all change to Pulumi, but if it's working for you, don't do it. Like, don't make changes within your organization that disrupt everything, but do think about things that could actually make things better organizational wide. And if you think that changing an infrastructure as code tool or choosing an infrastructure as code tool based on the things that I've already talked about could do that, let me help you. Like, I will help you make the right decision. The solutions that you should choose should be available to the lowest common denominator within your organization. So that means, just because you can do it and you've written a document saying how everybody else can do it, doesn't mean it's the right solution. And the one thing that really changed my career trajectory was starting to ask questions about how people wanted to do things instead of telling them how they should do things. So what do you want this to look like? How do you want this experience to be? And this is where this whole like authoring experience, execution experience started out. Like give people an idea of what they could do, but ask them how they want to do it. And infrastructure as code is no different from any other product. So what questions should you ask? What will provide the most business value? What's going to be increasing the productivity of organizations? It's security and cost are obviously a factor, but productivity can often offset cost. And then so ask yourself, what authoring experience do you want people in your organization to have? What do the vast majority of your users want? And then what execution experience do you want them to have? And how do you want that to look? You might have to do something you haven't done before. That's totally okay. It will probably be a net benefit for everybody. So I made a flow chart to help you kind of make this decision. It's a little tongue in cheek, but feel free to take a look at it. I'll leave it on screen for a second, just to give everybody who wants to read it a chance to scan the QR code. So final thoughts before we wrap up, and I think I'm just about right on time. All the IAC solutions that I've talked about now often offer multiple authoring experiences. I already talked about those. Try and find something that gives you the most footprint. And when you do, if you've decided that you want to use CloudFormation, let people use CDK. If you've decided you want to use Terraform, let people use Terraform CDK. If you've decided to use Pulumi, we've got all sorts of different options at your disposal. And then try new things. Like the one thing that I think is most exciting about infrastructure as code right now is that if you look at it again in a year's time, something new will have happened and something will have changed. And what's really great about that is that you're constantly pushing how things are working. Like I know that the new hotness is AI. Almost every infrastructure as code tool I've looked at now has this AI support with it. Like Pulumi has an AI engine. Terraform I think HashiCorp's just announcing an AI engine. Like a lot of this stuff really helps with the authoring experience. You no longer have to write it all out yourself. You can get somebody to do it for you, or you can get a robot to do it for you. And then the final thing that I think is really important when we think about even when making decisions internally in an organization, empathy, listening, asking people around you what they want to do. So feedback's really important to me. If you want to give me a feedback about either anonymously or with your name and an email address. If you leave your email address on this simple one-question survey, I will send you a free Pulumi t-shirt. Thank you very much for listening to me. I really appreciate it. And I hope you took something away from this that can help you rethink the way that you're doing your infrastructure as code.